Alright guys, welcome to 10.2. So this is going to be the first half, and then we'll do part 2 in the next video. What we're looking on these guys is the difference between independent and dependent events. So with probability, of course, you can have more than one thing going on, and so we're trying to see if those things are independent of each other, which means that they have no effect on each other. So if the events are independent, then the second event is not affected by the first event. And then dependent events is when they do affect each other. And so I'll kind of show you the difference here between those two things. So if you look at this one here, it's on page 288 of your journal. So if you look at these two, this is the difference between independent and dependent events. So if I was to take two different dice, and if I was to toss the first one and then toss the second one, is the outcome of the first one have any effect on the outcome of the second one? Right? And of course they don't. Whatever happens on the first one has nothing to do with what's going to happen on the second die when I give it a toss. So that's what makes these guys independent of each other, because they do not affect each other. The outcomes have nothing to do with each other. However, take a look at this one. We got 6 pieces of paper, numbered 1 through 6. They're sitting in a bag. We're gonna reach in and draw out a piece of paper, and then I'm gonna reach in and draw out another piece of paper. So when I reach in to draw out a piece of paper, right, there are 6 pieces of paper in there. So whatever I get has a 1 out of 6 chance of me grabbing that piece of paper. But if I reach in a second time and take out another piece of paper, well, now there's only going to be 5 left in the bag, right? Because let's just say I reach in and in my first pick, I come out with a 6, right? And this had a 1 out of 6 chance of happening. But if that's gone and I reach into the bag and grab another piece of paper, well, now it's only going to be a 1 out of 5 chance for any one of those numbers. And so here's a case where the result of the first event definitely has an effect on the second event, right? Because it went from 1 out of 6 in the first event to 1 out of 5 in the second event, right? And so that's what makes these guys dependent. So whenever you see something that says this without replacement, that just means when I pull something out of the bag on the first event, I'm not putting it back when I go in and draw out another one. If I did put it back, that would then make the two events independent, right? Because if I take out a piece of paper and it has a 1 out of 6 chance of happening, well, if I put that paper back and then draw out another one, well, now there's still a 1 out of 6 chance of those things happening, right? And so if I do put the first one back, then they're independent, but without replacement, then they are dependent events. So we're going to jump ahead here to page 290. So take a look at that page right there. So one thing to consider on this, and we've actually have already done this before, it's just we just didn't really give it the official formula yet. So when we have independent events, we simply multiply the two probabilities together. And that's really all there is to this formula. So if I'm going to flip 2 coins, right, of course if I flip a coin and then flip another coin, the second coin has nothing to do with what I got on the first coin, right? And so I could simply say, let's just say I wanted to say, what's the probability of getting tails on the first coin? And that's a key word right there. That always, in probability, the word and tells you to multiply. So we're going to get tails on the first coin, and let's just say heads on the second coin. So that's what we're hoping to get. Well, we'd say, what's the probability of getting tails on the first coin? Well, it's a 1 out of 2 chance. And what's the probability of getting heads on the second coin? Also has a 1 out of 2 chance. So there is a 1 in 4 chance of me getting tails on the first coin and heads on the second coin. So that's how that formula works. Let me jump ahead again. Sorry, we're going to go through a couple pages here of stuff. To page 291. So go down to the lower half of page 291 where it says extra practice, and if you look at the first one, all we're doing on this one is basically just figuring out which one of these is independent and which one of these is dependent. So if you're going along with the video, this is a great place to pause and give that a shot on your own. So on this first one, we got these 3 white golf balls and 2 yellow golf balls all in a bag. I'm randomly going to select one golf ball to hit now and another golf ball to put in my pocket. So I have 2 events going on, right? In the first event, I'm just taking one out to hit. And in the second event, I'm going to take out a second golf ball and put that one in my pocket. So those are 2 events right there. Well, in this one, it didn't say anything about me putting this one back before I took out another one. So if I reach into a bag and take out a ball, that now changes the probability on what's going to happen on the second time I reach in and take out a ball, because there's going to be one less ball in the bag, right? And so that's what makes these guys dependent, because they do have an effect on each other. However, if you compare it to the last one down here, so we're looking at guessing, kind of coming out with the last 3 digits of a phone number here, right? And so if I'm just randomly choosing numbers to come up with these 3 different digits, so consider the digits 0 through 9, right? So in this case, if I were to guess that, so we got 3 digits here. So if I was to guess that this digit is a 4 or a 5 or whatever, does that have any impact on the next digit that I pick? And in this case, it does not, because I'm allowed to repeat numbers. So if I pick a 4 here, well, I can still pick any number 0 through 9 on this one, right? I can pick a 4 or I could pick something else. So this one has no effect on the number that I choose here or here. So that's what makes these guys independent events. Okay. I'm going to jump ahead to a handout that I have made for you guys. And we're just going to look at the top half on these. So these are all independent events. And in the next set of notes, we're going to do the bottom half, which is our dependent events. So for the upper half here, so what's the probability of flipping 2 coins, getting heads on the first coin and heads on the second coin? And so we've already done this before with a little tree diagram, but today we're just working on using the formula. So again, I'm looking for heads on the first one and, keyword. Remember, and means multiply when you're doing probability. And heads on the second coin. So we're going to get heads on the first coin and heads on the second coin. So real simple, what's the probability that we get heads on the first coin? We know it's 1 out of 2. And heads on the second coin, also 1 out of 2. So in this case, overall, we're looking at a 1 out of 4 chance that they both come out to be heads. What's the probability of rolling a die? So a single 6-sided die, and getting a 4 3 times in a row. So I'm going to roll a die, roll it again, right? 3 times in a row. Again, these are independent, because whatever happens on the first roll has nothing to do with what happens on the next 2 rolls. So if we just said, what's the probability of getting a 4 on the first roll, we would say it's 1 out of 6. And getting a 4 on the second roll, and getting a 4 on the third roll. So what's the probability of getting a 4 3 times in a row? It would be a 1 out of 216 chance of that happening. So in other words, think of this logically too. That means I would have to do this whole thing 216 times in order to likely get this result 3 times in a row. So that's what that's telling us. What's the probability of rolling a die, getting a 2, then flipping a coin and getting tails? So what's the probability of getting the 2? Well, we know it's 1 out of 6. And getting tails on the coin is a 1/2 that I would get tails. So there's a 1 out of 12 chance overall of this happening, getting a 2 and tails. And then last one here. So what's the probability of randomly guessing all 5 true-false questions correct on a quiz? This one's always an interesting one, because if you think about it, if I gave you guys a quiz that was true-false, and it only had 5 questions on it, a lot of people would say, oh, well, this is easy. I can just guess, and I should probably do okay, right? Well, what's the probability? And this isn't very big. This is only 5 questions. So what's the probability of getting 100% on a true-false quiz that only has 5 questions on it? Well, what's the probability that you guess the first question correct? It'd be 1 out of 2. What's the probability that you guess the second question correct? 1 out of 2. The third question, the fourth question, and the fifth question. Right? So there's a 1 out of 2 chance that I'm going to guess each question correctly. So in order to guess all 5 of those correct is actually a 1 out of 32 chance of me getting 100% on that quiz. Right? So not likely to happen. So anyway, so you can see, especially with things like this, even with small numbers, things build pretty fast when it comes to probability. So anyway, that's all we got for the part 1 of lesson 10.2, and we'll get the exciting conclusion in the next one.